Okay. We're on page, what page is it on?
38.
We're looking at page 38 of the specification. It says, find graphically the intersection points of a given straight line. So let's say y is equal to 6x plus 7, and they're given with a circle. Okay, so we've got a circle, x squared plus y squared is equal, say, 12. Find graphically. Well, I'm going to alter that to 16. That's to make life a bit easier. Okay, 16. Right, now this means the radius of the circle is 4. The radius of the circle is 4. In this case, the centre of the circle will be at 0, 0. Right? So if you've got a piece of graph paper here and you've got to plot these points, all you need to do is put the compass there and draw a circle round something like that, where that will be 4, that will be minus 4, this will be 4, and this will be minus 4. Then we do this circle here, which, as I've got it at 7, it wouldn't intersect because 7 is going to be up here somewhere. Okay, so it's another bad example, thinking on my feet. If the circle had been a bit more complicated, which I don't think they'll give you, so that'd been minus 2 here, plus, say, y plus 3 squared is equal to, say, 25, then the centre of the circle will be at 2, comma, minus 3. It's the opposite of what's in here. Okay, next question. Yeah, forget all that. Communicating, explore. Okay, forget that. Forget that. Wait a minute, come back. Calculate, 1 minute. Recall the definitions of types of quadrilateral, including square. What's the definition of a square?
Four-sided shape with all angles equal and all sides the same.
Okay, right. Parallelogram
is two parallel sides, no, two-sided parallel sides.
Two pairs of parallel sides, right. A trapezium, one pair of parallel sides, just one pair. Yeah. Quadrilateral with one pair of parallel sides will do. And a rhombus
is
slanted.
Well, it's a shape with 4 equal sides. Now, under that definition, of course, a square is a type of rhombus. Okay. Calculate the angles in regular polygons. Okay, so you've got, say, this 1, 2, 3, 4, 5, 6. What's the size? How would you find the size of this angle there, which I'll call x? Well, you could do, or you could find the exterior angles.
Oh yeah.
So what do the exterior angles add up to?
180.
No, they don't. The exterior angles always add up to 360. So in this case, there are 5 exterior angles which will add up to 360. So each. No, they always take a square. That's supposed to be a square. That's an exterior angle. That's exterior. That's exterior. What do they add up to?
Oh, 360. Right.
Take a triangle. Let's take an equilateral triangle. If all the angles here are 60 inside, that's an equilateral triangle.
Okay.
Right. This exterior angle there would be that 120. This would be 120, and this would be 120. Yes. So the exterior angles always add up to 360. Okay. Then you can find the interior angle by doing that. 1 minute. Understand the use of SS. That's side, 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 for congruent triangles. I'm not sure I can do this quickly on here, but if you've got side, 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 if this is 3, and if this is 4, and if this is 5, then all triangles 3, 4, 5 will be identical. And if you ordered it on the internet, you wouldn't be disappointed. You get exactly the same product. Okay, and if you had angle, let's draw a triangle. If you had angle, side, angle, and you order them on the internet, you'd be okay. And also, if you've got a right angle, and if the hypotenuse and one side is okay, say that was 3, whatever, you wouldn't be disappointed. But if you ordered a triangle with, say, an angle of 30 degrees, and say sides of 5 centimeters and 6 centimeters, then you might not get the same triangle in different batches because they may not be the same. Understand ruler compass constructions. How do we do a 60-degree angle? How do we construct a 60-degree angle? Quick.
Measure.
2 points.
No, construct it.
Oh.
Draw equilateral triangle, basically.
Well, draw that round there. and then there, and draw down there. That would give us a 60 degree. How do we make a right angle at this point here?
Draw 90 degrees up.
Same way
Point,
as that,
what do you,
and then draw a line down.
well, put a point there and a point there.
And draw two.
Then a point there, there, there,
Isn't that
there.
perpendicular bisector or something?
Well, no, well, that should have gone through there. Well, it's the same thing, but look, all right. If I've got this line here, and I want to make a right angle here, I put the point on there, and I'll make an arc here and an arc here. Using that, I'll make an arc there and an arc here. Point there, I'll make an arc there and an arc there, and then I join them up. That should give me a right angle at that particular point. How would you bisect this angle?
You would put the
Put a point.
Compass on here, yes?
and mark two.
Mark there and there,
Yep.
point there, and join them up. And if you measure, if you print this out and measure it, you'll get 30 degrees, won't you? Understand similarity of triangles and other plane figures, and use this to make right. Understand, recall trigonometrical relationships in right-angled triangles. So you need to know that sine theta is equal to what? Sine is equal to what?
Opposite over hypotenuse.
Opposite over hypotenuse. You need to know that cos theta is equal to adjacent over hypotenuse. You need to know that tan theta is
opposite over adjacent.
Opposite over adjacent. Okay, right, we're on 400 seconds so far. Next bit. Calculate every triangle using half AB sine C. So you need to know half AB sine C. That means this side, this angle, and this side, or this side, and this angle. Okay, you can't mix them up. Use the sine rule. So we've got A over sine A, B over sine B, and then you've got the cosine rule that A squared is equal to B squared plus C squared minus 2BC cos A, or you could have cos A is equal to, I always put the minus A squared on the end, the B squared and the C squared can go where you want, so it's going to be 2BC. Explain why the perpendicular from the centre to the bisector chord. Can I explain that in 5 seconds? If you've got a circle, they're saying, what are they saying? Well, 1 minute. Explain why the perpendicular from the centre to a chord, there's a chord, perpendicular to the centre, and what they want to do? Explain why the perpendicular from the centre of the chord bisects the chord. Okay, they want to know why this is the same as that. Okay, we draw this to this. Now I'm going to use colour now. Right, so that red line here is equal to this red line here. Why?
Because they're both radius.
They're both radii, okay. And this line here is common to both of them. This line, this angle here, will be the same as this angle here. Why? Oh, well, no, that's not correct. What I've just said, it is correct, but that's not the reason. Okay, we said it's a perpendicular bisector, so this angle is a right angle, and this angle is a right angle. So we've now got side there and side there. We've got perpendicular here. That's a perpendicular. So we have hypotenuse, a right angle, and one side. So the triangles are similar. Therefore, this here is equal to that there. Do you understand that? So let's go through it again. The radii are equal. The radii are equal. We have a right angle. We have a right angle. Can't write on this machine. We have a right angle, and we have a common side. Because the blue side is common. Therefore, it's right angle, hypotenuse side. Therefore, the triangles are similar. Therefore, all the sides are the same. Therefore, the black lines are the same.